more. So if database is the easiest one, as long as you're one, but if you're in groups of more people, so you should figure out how to either run on the local system or maybe on AWS. Okay. So more people means you have something more to do, and maybe you need to do a little bit of Googling and how to see how to run those code on the local system. Oh yeah. Or AWS. Both of them are not terribly difficult, but it needs a lot of work from your side. Okay, so this is our last session. You don't have any final project, so we start from people who are in the class if they want to present. Also, please don't forget to review the course that you had with me. It's very bad from my side if nobody reviewed the course. So also, what's wrong? Nobody gave the comment. So please review the one. Regarding your comments, also last time your friend didn't like candies. This time I brought some chocolates. Hopefully you like it. So you can get that. This one I do not. The other one I So you can take that, then come to present. So you have your own laptop. So let me. Okay. Just, so I can let you to use your own system to do that. So now you can share your screen. So you can use my. Can you use my laptop? Yeah, I think that's easy. You just so you submitted over Moodle? You submitted over Moodle? No, yeah. No, yeah, we're just gonna. Or emailing me? That's... We're gonna put a PowerPoint on a thumb drive. Okay, that's fine. You're welcome. So take as much as you like. Okay. So this is my useful form. Yeah, I think you can figure it out. Oh, camera. Okay, now people have camera. You can use the mouse. Oh yeah. She should be down there. Cool.
Thank you.
Is it late for Hanukkah?
It's yeah, actually, it's very, very early for Hanukkah this year.
Oh, really?
So it's like I can only ever think of it being earlier than it was this year, like one other time.
Oh.
And that was like the earliest it can ever like actually happen. But yeah.
So hi, good afternoon, class. So morning, afternoon, post Thanksgiving, early Christmas. All right. So yeah, so our group, me, Tobias, and Thelma, we will be predicting the hotel booking cancellation as our final project. So more about this, about the content is that, have you ever wondered like when is the best time to book a hotel room is, or the optimal length of stay is, And from a business perspective, we want to come into like, what would the best, if the hotels are able to predict, what's the cancellation rate going to be, or how they can further enhance their profitability in terms of renting out the rooms and stuff. So we had this entire data set which we want to try to tackle with EDA, data cleaning, and machine learning. And that's the entire motivation of our project.
So we can do a lot more other things with the data set, but right now, since we're having this as like a business focused like mindset, we're going to be more focusing on the side of like, how can you predict how can you predict whether or not a reservation is going to be canceled? Because being able to figure out whether or not someone is going to cancel, and like, so you can actually just like reject it or do something with it, so you can actually keep the room open and get someone who actually is going to stay there, is going to be very, very profitable for a company in the long term.
So the data set is of a city in country called Portugal, Lisbon and Algarve. So these are the two places, and as you can see, Lisbon is on top and Algarve is over here. And from this, you can already tell that one of them is a city hotel, and another one is a resort. So different people have different perspective. So actually, I would prefer to go into a resort at any time than a city hotel. But our data kind of showed something different, and it will be very interesting that we would like to share this information with you. As for data, there's 119,000 observations with 32 columns, so it does satisfy our big data.
And then we also created a couple more columns for ourselves to play around with, because there was some interesting information that was still kind of left that we could like pick out.
Yeah, and going on to next.
So for the data cleaning first, there's a company called company, or there's a column called company, sorry. And originally it just had 94% valued as null, but then when we went through the data dictionary, it implied that null actually just means you didn't have a company. And so instead of just being nulls and then a couple numbers to identify like company ID numbers or something like that, we then reclassified it into being a 0 for 1. So if this person is like a corporate like member who's like staying here,
It's not a company.
it's a company. So it's like, we'll get there. And then we also reclassified agency, which is for travel agency. So it's again, it was a bunch. So instead of just doing nulls for nothing, we reclassified it again as 0. And then we kept then we made it agency values. And so it's yes, no, you have an agency. And this applies, you're instead of just booking from the website itself or something like that, you're booking or just like showing up to the hotel and saying, I want a room, and just doing directly like that. We're actually now looking at whether or not someone has like booked with a travel agency. And then so there was in the ADR, which stands for the average daily rate, there was a single negative value, and the negative value didn't really make any sense. It was much smaller than all the other values that weren't zeros, which is a value. So it wasn't just like they accidentally pressed the negative number. So there's only 1, 2. So we ended up just dropping it. And so we also reclassified the month name into just the month number versus like January's 1, stuff like that. It's pretty self-explanatory. And I believe that label classification like that should work, because throughout the year, there definitely will be like, there will be like a spikes and then like valleys and stuff like that on when people actually are going to be showing up. So when someone goes might also definitely have the thing. So we wanted to be able to use that variable still, but then parsing it as a string didn't necessarily sound like it was going to work properly. And then we also dropped a couple like variables that were highly correlated to each other. So like one example of this was like the week number versus the month, because for example, the fourth week of a year is always going to be in January. So they're kind of coding for the same thing. So we ended up picking month as the one we wanted to use, but we could have used either, but like they were highly correlated to it, so we couldn't have both. And also there were a couple variables that I don't know why they're on the data set, but they just had like a very, very, very low correlation between the actual independent variable we were calculating. So we just ended up not using it, but that was more feature selection.
So yeah, so give you an overall with the
let me give you a comment. So you actually did a very good job in terms of data cleaning. But dropping, yeah, I mean, let feature selection does it, because sometimes there is a non-linear relationship that you cannot show any statistical method to do that. But that's a good approach. Yeah.
Okay. So Before I go on to descriptive analytics, which I want to emphasize on the data dictionary part. So so that you guys have an idea of what we have. So it's the hotel, which I explained earlier, or it's here as well, like the city hotel, the resort hotel, the arrival date, the week, the month, the stay in the week of nights, the people who are there. So the people which we also bunch together with the total guests, such as adding all the adults, the children, and the babies together. Then the meal type served, booking were canceled or not. Did they book through the agent? Did they book through the company? If they were, or they were did it privately? And average daily rate, and did they pay a deposit? So these were all the factors that we considered, and we wanted to play with the descriptive analytics. And we're just going to show you a few slides of descriptive because there were a lot of things which we could play around with. So one of the things that we realized about this hotel, between the city hotel and the resort hotel, is that 37% of the time the city booking got cancelled. And while the booking guests did check in, almost 63% of the time. So, and more than 60% that got cancelled are from the city hotel. So these are the insights that we got from this and other graphs as well. And from this, we look at the market distribution, market segment by different hotel types. And we also realized that, wait, hold on. Oops, we made a mess.
So yeah, this is about the actual, like, what type of booking agency did you work with? And as you can see, there is a very large, so there's also just very large difference of the amounts of people that booked with different things. And so that could go into which of the methods is actually the most effective of getting someone into it. But there's also just very different amounts of bookings or cancellations between the different types.
So the market segment is actually our tour operators or the tour agents. So we just want to see if are people more comfortable doing that way or by themselves. So this is what we wanted to show.
Yeah, actually, sometimes if you make mistakes in the years, it happens. It's better not to have, but also you have a good skill how to go around it. Don't be just freak out. So yeah. I mean, you did a good job.
Okay. And also we wanted to check with the average daily rate. So we did a box plot. We wanted to see what's the range of price that these the hotels, the room type offer.
So
and
as give you a comment. So you have the one who knows everything from data set. I also know because I know what is your project, but the other people have zero, usually have zero. So no worries if you make a mistake. There's a low chance people can understand. So don't freak out, but sometimes people understand. So it's better not to have those mistakes.
Yeah, sorry about that.
Final report will not have that.
No, that happens. I mean, you should. I mean, this is a good skill how to go around it.
So we know that people are very sensitive to price, as we usually are, and we also realize that the hotels are charging extremely different price range, as you can tell from the interquartile range and from the minimum and the maximum. And this is one of the considerations we also took into note. And just by looking at this graph, we can tell that on average, city hotels are more expensive than the resort hotel. And I don't know why that is. I would really go into the resort hotel for that purpose. And there's also a large distribution from the room E and room F, has the largest distribution of price. Our intuition is that these hotel rooms are probably the more premium side, like the suite class or penthouse type. So that's our intuition on this. And so we wanted to go in further, realize. And this shows the combined reserve room with room type they were assigned to. And so we also realized that sometimes what the guests have booked and what they actually get are sometimes different. And how often does that happen? So it does turn out to be 80% of the time the guest does get what he wanted to book, and about 18% of the time he does not get what he wants. So I hope they get a bump up on the room for that. And this, we wanted to check on the days of the night they stayed in the hotel. So by that we have a good gauge. And what we realized that guests stayed up to 1 to 2 nights in the resort hotel, and the most popular, which is the most popular by that, and 7 to 8 nights is the next most popular thing, as you can see from the purple one on the towards the end.
So which software you use for making these figures?
This is in the PySpark, like when you do display, and then you can just like mess around with like the visualizations and stuff like that. We could have made it in Tableau. We could have done it, but we wanted to stick with
Yeah,
something.
I gave a comment carefully. Sometimes you can use them, but you should be very careful because the goal is not using those size. The goal is using PySpark that can manage everything like that. What can you do? You can say you wanted to show more visualizations, so you did a random selection of records, but you can just say this is just a pre-data exploratory, and what you did the main job in the PySpark. Good.
Yeah.
So actually, so intuitively, the 1 to 2 nights and then 7 to 8 nights makes sense, because if we're really thinking about the types of people that are staying in hotels, it's either businessmen who are going to be in town for a conference for 1 or 2 nights, which makes sense, and then families who are going to be on a vacation for like a week, so they're staying for a place for 7 to 8 days. So like those two values, they do make sense that those are the two most common things.
So those are the intuition that we went into, and I think kind of helps us to build up on our machine learning algorithms later. And this was the summary that we gave from other intuition, is that almost 35 bookings were canceled, 60% of the population booked the city hotel. More than the double booking were made in 2016. As also we have information on the countries as well. And so we noted that people are coming from Portugal, the UK, France, Spain, and Germany. These were the most top 5 countries. And most people stay for 1 to 2 to 3 nights that we already established. And for resort hotel, that's the most popular duration of stay. And for city hotel, it's a bit lower, 1 to 2, and 7 weeks and 3 respectively. And usually we always do with couples, which are the most accommodation type. As for the modeling.
All right, so for our modeling, we decided to use logistic regression, the random forest classifier, and then SVC. And SVC is like a subset of SVM, support vector matrix, or support vector machines. But because we're doing classification, we want to use the classifier version of it.
So what are your classes?
So it's is canceled, yes or no. So whether or not, so given a reservation and then various information about who they are, how much they're spending and stuff like that, are they going to cancel? And so our first model was logistic regression, and these are our performance metrics, and we already have a 0.824, and then all the other values are pretty high, and that's pretty good. And I personally like this model a lot because I've worked with this in the past, and also of the models we're using for the data set we're playing around with, it should be the best one, and it should be like the least computationally intensive for the project. So then we also use random forest, and this also around the same, but looking into what makes the two models different is that generally random forest is better when you have a lot more explanatory variables than just 30. And so for the scope of this data, this model is still very good, but it's a little bit overkill, I guess. So logistic regression works a lot better when you have a lot of observations, but not that many variables. And so surprisingly, when we did support vector classification, it was actually the lowest score, which genuinely surprised me because it's always been in my mind that it's going to be the most computationally intensive modeling program to run, but then it would also just be the best one. But as you can see, none of the metrics we get from here are better than the other ones. So overall, we can conclude that the logistic regression model is the best one for this type of project that we're working on. And from our model, we can find that the hotel type, the lead time, and then the month people are going in, and then other variables of essentially are useful in this thing. And so we're about 82% confident with our model to predict future cancellations, and that is a noticeable difference and a noticeable improvement from just a simple guess on whether or not they're going to do it, because that would just be a 50-50. And then so one specific variable impact that has a very large impact that we were able to see from our analysis is that the lead time is very, very important. It has the highest correlation to the actual value. It's of 30%. And so from this, one directly actionable insight we could have to our theoretical like shareholders in this theoretical like hotel company we're pitching this to is that they can generate marketing campaigns or just have more incentives for people to be booking their hotel stays closer to when they're actually booking it. So either that can mean they're booking later in the year to when they're actually going, or they could just be moving up their stays to that.
Okay. Very good present.
Yeah, lead time. Oh, so just in case you just some of us didn't understand. So lead time is actually the number of days elapsed between entering the date, the booking into the system and their arrival date. So that gap. So that is the lead time. So hence we found that is very correlated to the model. So the limitation and future work. So we obtained this data from public data from Kaggle, and some of this data set had a lot of null values that we have previously deal with. And there were undefined data in many columns as well that we also use data cleaning in our model. Regarding the modeling part, since we only had 3 classification models due to the time issue, other models may have also been have a different performance. And we would want to use that in the future to improve our models and check again how we could further improve it. In future, we would also thought that it would be a good idea to combine with weather of the city, the festive calendar, to further understand the seasonality. And that way we could also understand the further scope of the business problem to understand on the profit and losses by the hotels and how they could attract local customers by providing rates that are slightly above the break-even price, just during those times that they receive less foreign guests. So that will be a good approach to go with. Thank you very much.
Thank you very much. I just have a comment. So you use logistic regression. I think if you dig more into the documentation, you also can show the direction of each variable. So is it like so you talked about the importance of variable, but you can also check if more lead time. It means like more cancellation or less cancel. You can also get those directions. Other than very good project. Thank you very much.
Thank you so much. Does anyone have any question besides eating chocolates? Thank you. Thank you very much.
Good job. I think first you should close it if you want to safely remove. Yeah. Now we can safely remove that. So there's a question here. Yeah. Professor, for the final project, one group. Yeah, if you are in group, just one of you can submit. You don't have, not all of you. You don't have to submit together. So, do you want to present or you submit a file? Hey, could you see me? Kelly, do you want to present or I think you sent me email that you want to submit the file later, right? Okay, cool. So I think many of you just joined. So again, so for the people who are over Zoom, please provide your feedback for the course. I think university send you an email. It actually doesn't look good if nobody provides some feedback about the course. So please provide your feedback. Is there anyone from people over Zoom? Do you want to present today over Zoom?
Hi, Professor. This is Abby. Actually, I want to present tonight.
Okay.
Oh, I mean the afternoon. Sorry.
Okay, so just give me 1 second. I stop share.
Okay, sure.
I think now you can share your monitor.
Okay, so I'm gonna share my screen now.
Yeah, we can see yours now.
Great. All right. Good afternoon, everyone. So today I will bring my topic, the individual project. And so the topic is a bank loan default prediction. Let's begin with the introduction. So what is a loan default? A default occurs when someone owned from bank but unable to make timely payments, misses payments or avoid or stop making payments or interest. So as the time frame of bank loan becomes longer and the amount becomes larger, loan defaults such as delayed repayment or non-payment occur frequently. And the failure of those lenders to repay greatly affects the sustainability of financial and bank lending industry. So based on the background and the problem statement, this project will focus on first, to investigate the factors that contribute to the bank loan data performance. And second, to compare the various machine learning algorithm and select the best combination of the factors. And third, to find the most important variables that affect default in predictive model. So this is my data information. This data set is quite large that contains more than 80,000 rows and 11 attributes. So the variables are lender's ID, loan amount, terms of installment, loan grades, level assigned by bank, lender's annual income, their working years, loan proposed, loan default events within 2 years, and loan type and date of loan application. And the last one is default, that represents whether it's default or not. So this project is based on CRISP-DM as a project outline. As shown in figure, it contains 6 phrases. And now let's get into the data preposition part. So first, to deal with the missing values, I removed all the empty data sets and then without the duplicate. And after that, I did the missing value examination. And I figured that besides the employment length has quite much missing data, so but the rest do not need special process. So considering the large annual range of working times, I counted their mode to complete the data set. And then to make the modeling analysis more convenient, I converted these 3 complex variables with text. Those are employment length, grade, year, into the numerical form. And after other duplicate data removal, missing value, and outlier examination, the data set is ready for further analysis. So for the data analysis part, I did 2 steps for the project. One is descriptive statistics. The other is predictive analysis, using the different machine learning model to compare. So I will talk about the descriptive statistic first. The below chart shows the year-by-year loan volume trend using the time dimension as a benchmark. So I first combined the change in the number of loans for each year through 2019. So as can be seen from the graph, the number of loans from 2007 to 2015 showed a year-on-year increase, with a peak of number of loans in 2015 and a continuous decreasing trend from 2015 to 2019. And the reason behind the trend is influenced by the state regulation of macroeconomic policies and changes in bank lending rates. And to determine what factors will affect whether a lender will default the loan or not, I made a graph of the number of years a lender was worked versus whether he or not defaults the loan. So from the bar chart, relatively speaking, lenders with short working years are more likely to default than those who with long working years. But those who have worked for more than 10 years are an exception here. So they are the one who defaults the most. And the reason behind this deserve in-depth analysis.
Abby, which software you use for visualization?
The PR Spark, the just a normal plot, right? Yeah, bar plot. And this following two pie charts are used to determine if the type of loan affects whether a lender's defaults on loan or not. So the graph on the left shows the default for loans in an individual application, and the graph on the right shows the default loans applied with others. And the red is the percentage of non-defaults, the blue is the percentage of defaults. So it can be seen that the default rate of individual loans is much higher than the default rate of joint loans with others. As for prediction part, the target variable is default. That is to predict whether the lender will default on the loan or not. So a model was set for trained data sets with 80% and the test data with size of 20%. So below chart shows the results of logistic regression model. The accuracy of this model reached to 0.803. And the next one, this chart shows the results of the random forest model. So as the accuracy of this model reached around 0.805. So as a result, I found that model with random forest and the logistic regression perform quite the same, but the random forest has a better performance because it's highest AUC and the relative high accuracy here. And here's the model results that has printed at the end. According to random forest feature importance, I found that the loan amount, lender's annual income, and application time perform most important roles in predicting if the lenders will default on loan or not. So banks should focus on these features of lenders when predicting their risk of defaults. And to build better models, further research could focus on studying the importance of these factors and other machine learning algorithm, for example, more precise use of models to analyze the correlation between each element and whether not to default, and also finding new data sets containing more variables, including more detailed information about the lender, such as their occupation, the fixed assets, etc., to further analyze their financial situation and the status to make better judgments in their loan defaults. So based on the above data analysis, I draw up some business suggestions as well. So the reason behind loan defaults can be complex. In addition to direct repayment crisis brought by money flow difficult, some are the result of debater controllers, companies' funds into stock market speculation, and many reasons. So bank can allocate a reasonable amount of loan by the annual income of this lender, like their job position, etc., so as to reduce the risk of the lender not being able to repay. And when a lender is in default the loan, it is also important to develop a corresponding legal strategy. So in a nutshell, the core idea is that banks should get as much information as possible, I think, about lenders' financial information and lenders' financial status to control the risk of default based on multiple predictive models. So here's a reference link, and I think that'll be all. Thank you.
Thank you very much. You did a really good project. I like even you look at the importance of features. So you have two outcomes. One is finding which features are important. Second is a tool that's to predict if somebody can pay the loan or not. That's very good.
Right.
So before going to the next one, I'm going to upload two videos. So two types of videos. One is about Power BI. So I thought I'm teaching another class. So at the end of the video link, you would see the Power BI links and the files that I use. Also, I'm either today or tomorrow, I upload some extra material with Kafka. In case you're interested, you can just also look at that. But I think at least Power BI is necessary. It's one of the skills our employees are looking for these days. Okay, so anybody else wants to present? I think I seen a hand from Arjun. I'm not sure if you want to present. Oh, so he was clapping. Okay. So, okay, there's a question, I guess, here. Yeah, due date was today, but I extended to December 6th. Don't submit after December 6th. So, and the today was like giving feedback, so you can get feedback and still you should have 1 week to work on it. So don't submit anything after December 6th. Otherwise, maybe I missed your submission. And also, from tomorrow and weekend, you see your grades. I think most of your grades are really good, especially the final presentation was really awesome. I don't think somebody needs something bonus, but also you have a lot of bonus in addition. So your bonus is about your challenge. It was Adobe challenge, class participation, being active Telegram. If you still want one, so submit an article and explain what you learned in this class. So as you might remember, first we look at the concepts, then we seen that for large data set, we need to do parallel processing. And we have seen with Python is a lot more difficult. Even we had a very simple example over Hotel Sandbox, doing simple mean median was a lot challenging. So we then seeing that maybe we need Hadoop and Spark, which take care of the basically a platform side, and they provide the ecosystem. Then over Hadoop and Spark, we also had some experience in Peak, which was something like SQL, but in Peak. So, and as I said that time, if you know SQL, working with Peak is easy because almost same commands. It's they designed the way that working with large data management, large data set is easy. So basically, if you know SQL, maybe there's not that much need of learning Peak. You just need maybe do some hands-on experiences. Then we have seen for more advanced works, maybe we can use the Spark technology, and we focus on PySpark. There's a Spark R2, so it's for running or for doing machine learning AI for large data sets. So again, you might end up working in a company that they need a lot of you might have a lot of assignments with the large data set. PySpark usually they either most of the time if it's a small company they do through AWS, but sometimes for larger companies maybe they have some internal hardware that they run parallel processing. For those cases, if you want to have some cute visualizations, as you know, so far Spark is developing, but the number of visualization tools are a lot less than Python are. Maybe you can do random selection and randomly pick a good amount of data, download it, and maybe using R and Python to show off some of your sampling descriptive, but still you need to work on the actual data set. Okay, I don't see any questions. It was really good semester. It was my pleasure to work with you. I also learned a lot from you guys too. And please keep in touch. I'm very happy that seeing many of you getting really good jobs these days, and some of you actually missed the class today for the interview. So hopefully I see good news from you guys. And that's for this semester. Please don't forget to put the review for the class. Okay, thank you very much and take care.
Thank you.
You can clap for yourself.